Testing for symmetry is that we are applying f of negative x, or we're evaluating the function at negative x and seeing if it comes out to be the original function or the opposite of the function. This way it will be even or odd. If it doesn't come out to be either one of these, it'll be neither even nor odd. Let's crank through some of these. We're going to apply negative x to the function. So we have 3 to the negative x to the fourth. We'll just apply each one of these negative x's in place of x. And notice that 14, it does have a power, and it does have an x, but it's x to the 0. So we still want to make sure that we are applying that. Now, x to the 0 is just 1. Negative x to the 0 is also 1, so it's still going to be 14. Let's simplify this. Negative x to the fourth. Well, a negative times itself 4 times is going to be positive. So this remains 3x to the fourth. It's still positive. X squared, or negative x squared, negative times a negative is a positive. So this is still negative 22 over 7 x squared. This is negative 1x. So it's negative 1 times negative 1 is positive 1. So the coefficient out front doesn't change. We already mentioned this. Anything raised to the 0 power, besides 0, is 1. So this is 1 times 14, which is 14. Notice that negative f of negative x is equal to f of x. 3x to the fourth, 3x to the fourth. Each one of the 3 terms is identical to the original term. So this is indeed even. Moving on to odd. We're going to substitute negative x everywhere we see an x in the original function. So we rewrite everything except replacing a negative x in for our x. This is the same as if we were going to evaluate it, say like f of 2. We're going to replace all of the x's with 2. Just in this case, it's with negative 1x. 5 negatives multiplied together is going to be a negative number. So this changes to a positive 22x to the fifth. 3 negatives multiplied together is going to be a negative number. This is negative 1 times negative 1 times negative 1 is negative 1. So negative 1 times negative 13 is a positive 13. And the x cubed stays there. This we could just say it's root 3 over 2 times negative 1 times x, or just negative root 3 over 2 times x. Comparing this to the original function, we had negative 22x to the fifth. Now we have positive. We had a negative 13x cubed, then a positive, then a negative. All of the signs switched. So everything had switched. Our original function was now negated. Hence, an odd function. Applying the same rule, negative 2 times x to the fourth. We replace the x with negative x, so negative 2 times negative x to the fourth, plus 8 negative x cubed, plus negative x squared, divided by 3, minus 72. Again, we have an x to the 0 here, so it's negative x to the 0. Simplifying those, we have x to the fourth, or negative x to the fourth is a positive, so that doesn't change the sign. 3 negatives changes the sign. 2 negatives does not change the sign. It remains positive. 0 negatives doesn't change the sign, so it's still negative. But I'll omit the x to the 0 because it's redundant, because x to the 0 is 1. So we see that f to the negative x is, let's see, a negative turns to a negative, remains a negative, a positive turns to a negative, positive stays a positive, negative stays a negative. we only had one change and 3 not changed, so this is inconclusive. Well, it's not inconclusive, it's just neither. Sorry, I had to stifle a sneeze there. Neither odd nor even. Let's look at this a little more closely, a little objectively. Notice that all of these exponents, x to the 4th, x squared, x to the 0, 0, 2, and 4 are all even exponents. For the odd function, x to the 1st power, x to the 3rd power, x to the 5th power, they're all odd exponents. Oh no. You're saying, why didn't you tell me this in the first place? This could have been much easier. Surprise! Look at the exponents, 0, 2, 3, and 4. Even, even, odd, even. Oh, there's a mixture of even and odd exponents. So it cannot be even or odd because there's a mixture.